And we're back. Graph of this sucker with our end behavior. Excellent. Okay, so we have a first power here, first of all, which means to cross through at the opposite sign. So at x equals 4, we're going to go ahead and cross through at x equals 4. And so we're going to go 1, 2, 3, 4. It's going to cross through. And then this will be at x equals -2, right? So 1, 2, -2, it's going to bounce. And then what you have to do is decide the end behavior. Well, how many x's do we have? We have x to the first power and x squared. So x to the first times x squared is x to the third power. So this is going to be a cubic. Awesome. And so cubic is John Travolta, remember? Picture those as his hands pointing to up and to down. John Travolta, do it. Yeah, Pan, do it. There we go. So we're going to go ahead and do John Travolta. So that means up and to the right and down and to the left. And I'm going to go to a more. Alrighty, and we're back. There we go. Okay, so do an end behavior. So x to the third power goes up to the right and down and to the left for x cubed. So another one would be like, for example, number 6. And so number 6 actually has an x to the third and an x to the first. And so x to the third and x to the first. So when you get those together and add the powers, it's going to be x to the fourth. And so x to the fourth is an even number. And so even number means what? Means both going upwards. Or if we had a negative in front, like that, so a negative sign in the front, then it'd be both be going downwards. Remember that? And so finishes to the right if it's negative. Same with this one. There isn't one, but if there was a negative in the front of the equation, then it would reverse it, and we go down and to the right and up and to the left. Just to give you a heads up reminder about all that. Those are the only 4 options. Up, up, down, down, left, right, A, B, start. Oh, that's Nintendo code. Infinity Lives. So no, I mean up, up, or down, down, and then, yep, and then up and to the right, down to the left, or up and to the left, down to the right. Those are the only 4 options. Cool. Okay, so now we want to go ahead and graph this sucker. And so to graph this, we could also do the intercept. The y-intercept, remember that? So the y-intercept is plugging in, setting x equal to 0. So if x equals 0, we plug it in there and there. We're going to get 2 squared is 4, and 4 times 4 is -16. So that'll be way down here at -16. Good. And so now we're going to go ahead and follow now. So because of this 2, at -2, because of the 2, we're going to go ahead and bounce at 2. So we're coming along. We're going to go ahead and bounce. We're going to go through the y-intercept because it crosses at the y-intercept. And then at x equals 4, it's a 1, and which means we're going to cross through at 4. So at 4, we're going to cross through, and there's our graph. There's our graph. Okay, so the end behavior again. As x goes to -infinity, y goes to -infinity. Awesome. I guess a little arrow. And then as x goes to the right, positive infinity, y goes upwards to positive infinity. Beautiful. So number 6, though, we have cube. That means wiggle through, right? I don't know if you remember that. So that means to slide through or wiggle through. And this one just means to cross through. Awesome. So we're going to use that x equals not -5, but 1, 2, 3, 4, 5. We're going to cross through. And then at x equals 1, we're going to wiggle through. Cool. So now the end behavior, though, is going to be even and positive. So both up. Positive, good. X to the fourth, even, positive. So we're going to draw arrows up there and there. Awesome. So both going to be going upwards. So then we're going to come along here. And when we're going through that 1, because it's a 3, we're actually going to cubic. We're going to wiggle through that 1. So we're going to come along. We're going to wiggle through it, go down. Then at x equals 5, we're going to go ahead and cross through it. Just like that. So there's our graph. And so both are going to be positive, right? as we go to the right. So both are going to go ahead and be positive. Awesome. So positive infinity. As x goes to the left, positive infinity. Y goes to the right, positive infinity. As x goes, you know. I've done enough of those for this review. I should need to move forward. Cool. Okay, excellent. So we're looking at the next one now. Ooh, piecewise functions. Name the domain and range of the following graph. Okay, so the domain is the x values. I don't see arrows, but I'm guessing they're supposed to be. Sorry about that. Don't know why they didn't put arrows on there for you. There we go. Guessing there's supposed to be arrows there. So then our domain is the x values, right? So here's our x values. So -8, -7, -6, all the way to -infinity. And so -infinity, we're coming along. And then, oh no, we have an open hole there. But because there's directly a hole right above it, it is technically going to fill that in. So we can carry on. So -infinity down to -2, and then carry on to 1. And so we're going along, we're going boop, boop. So that's just going to be, because there's an open hole is filled in by the closed hole like up above, we can just count that in our domain. So really this will be all real numbers, or you could say -infinity to positive infinity. But what will be different is the range, okay? So let's take a look at the range now. Erase, erase, erase. Okay, so for our range, we're looking at, let's take a look. So this arrow is continuing on forever, so we are going to do -infinity. So the domain is from left to right, x values only. The range is from down to up, right? So down to up is the range. Cool. So now we're coming along that range from down to up. So we start off at -infinity, start off at -infinity. We're coming along. Let's do a red line this time. And then, oh no, there's a hole. Oh, but it's filled in because of right here. So carry on. Still matches. We're fine. Keep on. Still in a range. Still in a, all these numbers are in a range. Oh, no hole. Oh, lucky there's something there. And then we stop right there. So that's it. -infinity, and then we stop at 4. At y equals 4. So there is our range. So -infinity to 4. Make it all red. Okay, describe the transformation of the solid lines to the dotted lines. So if you take a look at that transformation, it looks like we are going up 1, 2, 3. So up 3, and then left, right? Then we're going left 1. So up 3 and then left 1. So how we would describe that transformation is you'd say f of, and then x, and then we're doing left 1. And so since it's left, you have to think opposite. So when you think left, you usually think -1, right? But it's going to be +1, even though we're going to the left, because you have to think opposite, remember? And so this is the notation they want you to use. You're going to see on the test. So we're going to go left 1, and then don't forget your up 3. And that's it. So there's number 8. There we go. So now we're looking at number 9 next. What is the most likely factorization of the polynomial below? Factorization. Awesome. So they're thinking about just the factors. So they're talking about like a +1 basically, and a -1 is where it crosses and bounces and does stuff like that. And so let's see here. So it looks like it just crosses through, doesn't even wiggle. So since it crosses through, it's just going to be like a to the first power. And then this one does bounce at 1. And so that means it's going to be a squared, because squared means to bounce. And so this is at x equals 1. We need to reverse the back turn and put it into factorization form. So that means -1 to both sides. And so when we do that, 1 minus 1 is equal to 0. There it is. So that's going to be our 1, parentheses, x minus 1, 1 for +1. And then the other one over here will be the opposite of -1. It'll be +1. And there you go. So y equals x plus 1 to the first power times x minus 1 to the bouncy bounce squared power. Cool. There we go. Let's see here. Excellent. I think even maybe possibly no, yes, no, yes, no, yes, no, yes, no, yes, no. Won't go there. Okay, beautiful. Most likely is what the phrase says. So maybe not exactly, but most likely. Okay, graph. Radicals. Remember radicals is a rocket. Rockets explode. Howdy. Woody. Howdy. Buzz Lightyear. Rockets explode. Time. So square roots. Square roots, basically. So think about square root of x. If you plug in a 0, you will get a 0 back. If you plug in a 1, you will get a 1 back. And so what happens if you plug in a 2? You get a decimal 1.73. What about a nice perfect square like 4? If you plug in a 4, you get 2. So this is like your xy table. And so we plug in a 4, square root of 4 is 2. So there is our parent function. And now we're going to do some transformations. So that negative 5, do you know what that means? Come on. That's right, opposite. So not left 5, but right 5. So we're going to go 1, 2, 3, 4, 5. Put a big old dot there. And then up 3, 1, 2, 3. Put a big old dot there. And then because there's no number here, like this 2, if there was a 2 there, it'd make it go higher, faster. But there's not one. Awesome. Over 1, up 1. Remember that? Over 1, up 1. And over 4, up 2. 1, 2, 3, 4, up 2. And so there's our graph. The domain is going to be the x value, which our x value is 5 to infinity. Right? This 5 down here to infinity is this graph. And so that'll be our domain. Include it. Oh, okay. So then we'll go ahead and do bracket 5 to infinity. And then the range will just be our y values. Remember our y values, 3. So because of the up 3. Oh, cool. That's our, interesting. So that goes there, and this goes here. So we're going to go 3. Why did it do that? Let me try one more time. It's going to go 3 brackets, so 3, and then upwards to infinity. So 3 to infinity. There we go. Next video.